this last video, we're going to be going the other direction compared to the first two. We're actually going to be writing series in summation notation if we are given them in expanded form. And if you think back to what summation notation looks like, there's really going to be two pieces of information we have to fill in. We have to fill in the final value for k, which will require us to know the number of terms in the series, and we're going to have to fill in what the explicit formula is that lets us find each of those terms. So if we jump into an example, 3 plus 6 plus 9 plus 12, there are 1, 2, 3, 4 terms. So right away we can fill in that we're doing the sum from k equals 1 to 4, right? The sum of the first 4 terms. And if we want to write an explicit rule for this, a sub k, well, we know we are repeatedly doing addition. We're adding plus 3 every time if we look at the pattern here. And if you think back to what we were working on before, when we're doing repeated addition, we can write that as multiplication. In this case specifically, we're to do repeat addition by 3. That will be 3 times k. Now we might have to modify this a little bit, but let's check to see if it works right now. If we plug in 1, we do get 3. If we plug in 2, we do get 6. If we plug in 3, we do get 9. If we plug in 4, we do get 12. So this does work for all our terms, which means we can now bring it over here. That is our explicit formula that lets us find each of the terms in this series. So that will be our final answer. Let's look at one more example. Again, we can really quickly identify that there are 1, 2, 3, 4, 5, 6 terms. So this must be the sum from k equals 1 to 6. Now we should figure out what the rule is that lets us find each of those terms. Well, we're not adding or multiplying by anything over and over again, so it's neither of those options. And because of these fractions that seem to follow some pattern, I'm thinking it might be a rational sequence where it's going to be written as a fraction. So in the numerator, we just go 1, 2, 3, 4, 5, 6, which means it's probably just a k up there, right? We're going to plug in 1, 2, 3, 4, 5, 6. And the bottom is always just 1 higher than that. It's 2, 3, 4, 5, 6, 7. So maybe this is just k plus 1. Well, let's go ahead and check, does that work? If we plug in 1 for k, we get 1 over 1 plus 1, which is 1/2. Let's test another one. Let's test the fourth term. If we plug in 4 for k, we get 4 in the numerator, and we get 4 plus 1 is 5 in the denominator. So this rule does seem to work, which means we can bring it over here and write it as k over k plus 1 as our explicit formula for this series. And again, there is our series written in summation notation.